Okay, let's get started. I'm going to give you guys a couple of hints about problem set number 4 because it appears that I have created some confusion. All right, how about this? In a fairly quiet voice, I'm going to give you the answer to part 1 of problem set 4, but you won't hear it if you're not listening carefully. So problem 1, problem set 4, asks you to sort through some consumption savings decisions, consumption savings and borrowing decisions. There are a couple of things about this problem that make it more troublesome than I would have liked. One of them is that it actually turns out to be very difficult to simplify a consumption savings borrowing choice setting enough to make it sort of manageable for problem set, and I think I simplified it in ways that are almost too goofy, like the idea that basically the linear utility for money and things like that. But try to get clear on what the setup is trying to represent. The second reason that I think it's a little bit more troublesome than I hoped is that it's actually not simple enough, or I didn't sort of explain it in a simple enough way. So let me say a few things. First of all, and this may seem a little bit counterintuitive given what I've said in lecture, don't use a game tree. Okay? And I really want to emphasize this. The logic necessary to solve intertemporal decision-making problems with the beta-delta model never changes. It never changes. It works like this. In any given period, each person, whether they're naive or sophisticate, looks into the future to evaluate the plans that they believe to be available to them, and then acts out the first step in whichever plan they prefer from among those that they believe to be available to them. However, the difference between the naive and the sophisticate is that the sophisticate correctly recognizes that certain plans aren't available. So she winnows the unavailable plans from her choice set, figures out which of the actually available plans she prefers, and then acts out the first step of that plan. The naive, instead, looks at his plans and says, I believe I can follow through on any of these, so he acts out the first step of his preferred plan, whether or not he'll follow through with it. It's always the same. You can use a game tree to do that, and there will be certain problems in which that's actually a very helpful tool. You can use a table of utilities to do it, and there will be situations where that's a helpful tool. Or you can just abandon both of those devices and just think it through. Just think it through. Okay? What does each of these people predict? And given what they predict, what will they want to do at each stage of the process? Now, to make matters a little simpler on this problem, two things. First of all, the savings decision does not affect the borrowing decision. You have enough information in the problem to figure that out for yourself, but I don't want you to waste your time on it. In this particular setup, and this is because of the assumption of linear utility, right? That C of x equals x, or whatever you want to see of something, U of x equals x. It turns out that the decision of whether or not to borrow can be made completely independent of the decision of whether or not to save. They don't affect one another. It's not as if you choose to save, then borrowing is less valuable to you. Because of linear utility, these things wind up being independent of one another. And the other thing, for the same reason, because of the linear utility function, these choices are both actually binary. Okay, you either save it all or none at all. You either save all or none. If you're going to withdraw from savings, you either withdraw all or none. If you're going to borrow, you either borrow all or none. Right? Because of linear utility, if it's worth it to you to borrow $1, it's worth it to you. Each dollar is worth the same, so it's worth it to you to borrow all 10. All right. These two things you would have figured out for yourself if you thought about it, but that's not what I'm testing you on. This is just a hint, because I've emphasized game trees as a tool for doing backwards induction more this year than I did in the past, but haven't changed the problem set, so I just wanted to give you guys a heads up. This problem will actually be easier if you don't use a game tree. On the other hand, certain problems I think are easier with a game tree than without, and you just have to learn various tools and have the ability to figure out which one is going to be helpful in a given situation. Okay, on to the topic at hand, which is state-dependent preferences and whether or not people predict change in their preferences when their state changes. Showed some examples of what I mean by state-dependent preferences: hunger, sexual arousal, reference point adaptation, things like that. Now, I want to clarify, there's a difference between whether or not you predict that your state will change and whether or not you predict that your preferences will change when your state changes. Okay? So you all know that between when you begin dinner and when you end dinner, your state is going to go from hungry to not hungry. The question is not whether you predict that, but rather whether you predict how that will change your willingness to pay for more food. And these are two separate issues. We're going to assume throughout this section that people correctly predict the state change, and the question is going to be, do they predict the effect that has on their preferences? I guess that was supposed to come first. Study guide and class exams have been posted. Exam review next Tuesday. That'll be a GSS. Okay, so here, these studies are all on B-Space, and I think they're all quite fun. Reed and Van Loen, I think that's how you pronounce that, conducted an experiment with food, and we talked about how shopping experiments are suggestive of projection bias but not conclusive. But this study, I think, is pretty conclusive. Okay, so you get a bunch of subjects. These were workers in some office. I think there was, 140 of them, not sure. Subjects will choose today what snack they want to receive in 1 week, and they had a choice of like apples, carrots, healthy stuff versus chips and candy, unhealthy stuff. So I'm going to go in on week 1, and I'm going to say, look, I'm going to bring you a snack next week, for sure, some snack. And it's going to be either a healthy or an unhealthy snack, depending on what you ask for. Then they randomize people in the following 2 ways. First, they randomize when they make their choice in week 1, either right after lunch when they're satiated or later in the afternoon when they're hungry. Okay, so they have predictions in both the satiated state and the hungry state, and then they also randomize them on when the snack would be delivered, either right after lunch or at the end of the day. So we have variation in the state they're in when they predict, variation in the state they're in that they're predicting for. Okay, now if you've been hungry before and if you've been satiated before, which these people presumably had, you should be able to predict the state change. The question is, do they predict the change in their preferences? First of all, you should know, which the study makes clear, these people, when they're hungry, do indeed prefer unhealthy snacks, and when they're satiated, they're much more likely to choose healthy snacks. So then the question is, what do they predict? Right? So in other words, if I choose in advance healthy snacks when I'm not hungry, it suggests that perhaps I don't realize that when I'm not hungry a week from now, I might prefer a healthy snack. Okay, so here's what they got. These numbers are the proportion, or in fact percentage, choosing the unhealthy snack. And what do we see? What we see is evidence of a couple of things. Subject to anticipated being hungry. So the way this is, this dimension is the state they're in when they make the prediction, and this is the state that they'll be in when they receive the snack. So subject to anticipated being hungry, that's to say people in this column, when the snack arrived, were more likely to opt for unhealthy snacks, okay? So what that says is that they correctly predict that when they're hungry, they will want an unhealthy snack more than when they're not hungry, okay? So they're correctly predicting, in some sense, the direction in which their preferences will change. So let me just sort of put this in terms of the notation that I've shown you. The 78% of people choosing healthy snacks when they're in a hungry state, choosing for a hungry state, being greater than the 56% who choose unhealthy snacks when they're, for a time when they'll be in a hungry state, but currently they're, so these are both people predicting when they're hungry. These are people predicting for when they will be hungry, and this is people predicting when they're hungry for when they won't be hungry. The fact that this is bigger than that tells us this. It tells us that their predicted utility for chips, okay, as a function of their hunger state, right, their predicted utility for chips when they're hungry, given that they are currently hungry, right, that's what determines how likely you are to say you want chips when you're hungry in the future if you're hungry now, must be greater than their predicted utility for eating chips in an unhungry state, given that they are now hungry. Okay? So this says what state they're in now. This says what state they'll be in the future. So this is people who are hungry when they're predicting, okay? And what they're predicting for is, in the future, how much will I want chips when I'm hungry? In the future, how much will I want chips when I'm not hungry? Okay? And what we see is that people correctly predict, when they're in a hungry state, they correctly predict that when they're satiated, they won't want chips as much. Okay? The question we have to ask is, do they predict enough of a change? Do they fully appreciate how much their preferences will change? Okay? Second thing we observe is this. Subjects who were hungry when they made the choice were more likely to opt for unhealthy snacks than people who were satiated. Okay? So I'm going to compare this number with this number. This is people, both of these sets of people are predicting for what they'll want when they're hungry. These are people who are currently in that state. These are people who are not in that state. All right? And so what we have, very similar math, is that the fact that 56% of people predicting they'll want, of choosing, sorry, did I say 56%? Where do I want to be? Anticipated being hungry when the snack arrived. More likely to opt for unhealthy snacks. Oh, it turns out you can do this off of either column. So let me... All right, I'm going to mess up. So what are the numbers? 78% is more than what? What's the bottom one? 42. Now this is where you get to see whether or not I can actually think on my feet in front of an audience. So what that says is that the predicted utility of eating chips, of eating chips in the future when you are hungry, predicted in a hungry state, right, is greater than the predicted utility of eating chips when you're in a hungry state if you're predicting in a non-hungry state. Okay? Now, if we make the not hugely unreasonable assumption, I think, not hugely unreasonable assumption, that when people are satiated, when people are hungry, they have a pretty good idea what they'll want when they're hungry. What this says is that when people aren't hungry, they fail to appreciate how much they will want unhealthy snacks when they're hungry. Right? So this is saying how much will you want an unhealthy snack when you're hungry, given that you're currently satiated? We make the assumption that these people's predictions are basically pretty accurate, and it turns out that they were. These people are underappreciating how much their preferences will change. Not enough of them are realizing that they will in fact want unhealthy snacks when they're hungry. Okay? So the stylized fact is that people predict the direction in which their preferences will change, but not how much. Okay? All right. All right. Here's a couple of other case studies, if you want. So it's really important for you to notice that the last study I just showed you, which was relatively sort of PG in nature, did not include either George Lowenstein or Dan Ariely as a co-author. The next two studies I'm going to show you both have George Lowenstein involved, and one of them has Dan Ariely, and they are monotonically increasing in how absurd, not absurd, but how like what, really, you did that? Okay, so hold tight. So this is Giordano et al. And Lowenstein is buried in the et al. Heroin addicts. Okay, it's funny. The first time I taught this class, I said I'm just going to go out on a limb and guess that none of you have ever had the experience of heroin addiction. And then someone came up to me in my office hours and said, "Actually, I'm a recovering heroin addict. I'm interested to talk to you about blah blah blah." So anyway, you never know. You get all sorts at Cal. Great guy. Okay, so here's the deal. People are addicted to heroin. They come into a clinic. They're trying to not take heroin, because heroin is actually really bad for you, okay? So they're trying to not take heroin, but it's also incredibly difficult to not take heroin if you're addicted to it. It's incredibly difficult. So what they do is they give them a heroin substitute, okay, that takes away the craving, but does not do all of the other crazy things that heroin does to you, okay? It doesn't make you, for example, want to crawl into a dark place and just curl up in a ball. So they come into the clinic on 2 days, day 1 and day 5, and no matter what day they come in, they're going to get their base dose of this stuff called BOOP, which is this heroin substitute. And the BOOP is going to take them from a state of being heroin deprived to a state of being satiated. So, right, from craving to satiated, okay? And this is a very predictable state change. They've been through it many, many times. It's kind of the whole point of their existence. I actually know quite a lot of recovering heroin addicts, so I have a pretty clear idea of what this is like. So then they elicit willingness to pay for a second dose of BOOP, right? Now, once you're already satiated, a second dose of BOOP, I don't actually know what that feels like, but I'm guessing it still feels pretty good to get another dose, but you're no longer in that just like insane craving. I had a friend who called me up on the 4th of July and said, I'm kicking heroin. I'm in my friend's parents' house. They don't know that I'm kicking heroin. Can you please come and get me? So I took him to this picnic that I was at. And the guy crawled into the bushes and just lay there just kind of throwing up. And the first dose of BOOP takes that away. The second dose of BOOP is just kind of nice. Okay? What we want to know is how much would you be willing to pay for that second dose of BOOP on day 5, conditional on either having had the first dose or not. Okay? So the question is, before you had the first dose, do you predict the way in which your desire for BOOP is going to change after you've had the first dose? Okay? I mean, this is no different than predicting how much you're going to be willing to pay for a second hamburger before you bought the first one, right? Okay, so they did 2 dimensions of randomization, which are a little bit different than last time, so pay careful attention. They randomized when the elicitation was done, either on day 1 or on day 5, two dimensions of randomization in when the elicitation was done. So there's no difference in when the boop is delivered. This is always you're valuing the second dose of boop, the boop in a satiated state. So you're eliciting either on day 1 or on day 5, and you're eliciting either before the base dose in a deprived state or after in a satiated state, right? So 4 elicitations, 4 different groups. Day 1, before your base dose, you come in, I grab you, you're shaking, and I grab you, and I say, how much would you be willing to pay 5 days from now or 4 days from now for a second dose of boop? And you're sitting there going, are you kidding? Get out of my way. And then the next group, I give them the base dose of boop on day 1, and I say, how much would you be willing to pay for a second dose of boop 5 days from now, right? So now you're satiated. You're thinking, okay, well, I'm going to be satiated. Oh, I might pay you some. And then it's the same thing on day 5. Some of them I come on day 5 before the first dose, and I say, how much would you pay for a second dose right after the first one? And some of them, you take them right into the moment when you're going to give them the second dose, right? It's on the day, they're in the satiated state, you say, how much would you be willing to pay for a second dose of boop, okay? And here are the results in median willingness to pay, okay? So the subject is satiated at the time of the second dose, right? So not necessarily at the time of the elicitation. So what we see is, right, here's satiated second, this is I'm right in front of the dose. I'm satiated, I'm just about to get it, I'm willing to pay $50 for a second. So you can tell it's still pretty nice stuff. What we don't know here is how much they'd be willing to pay for the first dose, but I can tell you the answer, which is everything they can possibly get their hands on. This is them predicting right before the first dose on that day. They say they'd be willing to pay $75. Here's them saying how much they'd be willing to pay on day 1 for a second dose on day 5. Why is that less than $50? Because of what? Because of discount, because of beta. And the same thing here, 60 relative to 675. Okay. Quickly, I don't think you're going to need to do this in groups, particularly because I just gave you the answer. Which two numbers provide evidence of misprediction of state dependence? It's actually more than one answer. Which two numbers provide evidence of misprediction of the state change, of the state-dependent preferences from satiated to from deprived to satiated? There. What? 2 seconds. You gotta be what? Just do it. It's not accepting your clicks. Is that right? Yeah, I had to change the frequency because someone else in the building is using. You can change it on your clickers. Okay, change it. It's BB. How do you change it on your clicker?
Your power button, and then we start flashing.
Okay, let me just demonstrate. You press the power button and hold it until the power button starts to flash, and then presumably you press B and then B again. Good? Thank you. All right. Kudos to you. What? The older version doesn't do that? Okay. Okay, so hang on. Quiet. Is there anybody who has not solved this problem? Everybody solved the problem. You haven't solved the problem. So social welfare maximization would say I throw you under the bus and move on. Have you got you're dialed in? Okay, good. 2 copiers didn't work on me today. Then BSpace was down. I don't know if you noticed this. And then the projector in my first class didn't work. And then my laptop didn't work. Now this. Okay. All right. So answers. Everybody click. 5, 4, 3, 2, 1. Come on. Okay, stop. All right. So what did you say? A, B, C, and D all offered as possible answers. Who said? Let's see. Who said A? Yeah. Oh, sorry. I'm asking the wrong. I'm sorry. Oh, 35.50. Yeah. Go ahead. That's the self-control issue, right? That's the present bias issue. What you just described, what I heard coming out of your mouth, was the beta. So this is giving us evidence of their beta. Okay? So that's what A does for us. And 60 versus 75 would do the same thing, right? Now it's interesting. The reason they actually set out to do the study was to see whether beta varies depending upon your drug state, which it turns out to be mathematically the same thing as figuring out whether or not you predict the state change. So let's look at some other possibilities. 75 to 50, just a few of you said. 75 to 50 tells us what? What's 75? 75 is you're predicting in advance, but just in advance. So beta's not involved. Your desire for a second dose of boop after the first dose. But you're sitting there at the first dose. You're like, well, first of all, let me tell you, I would give you most of my left leg for the first dose. So let's just get that out of the way. I want to go on the record. And then second dose, yeah, I really like boop. Please just give me boop. I'll give you $75. I've only got 60, but take my left arm. And then you get the second dose and think, no, I'm not going to do it. I want my $25 back, right? Because you have mispredicted in that top right corner the fact that immediately after the first dose you're going to desire the stuff a lot less. So that would be perhaps the most direct test. This is another one, right? This also tests. This now contains both beta and the misprediction of the state change. Yes, good. So so A works and D works. Okay. Yes. What? C and D work. Wait a minute. C and D work. Yes. Thank you. C and D work. Okay. So let's do a little bit more math, and this is really important because this is going to inform part 2 of problem 2 on the problem set. So one of the things, yes, okay. Why B didn't work? So B was 60 versus 35. Oh, I see. Well, that's what I said was evidence of misprediction in the chips thing, isn't it? Okay, yeah, no, that's right. You're right. Thank you very much. So B also works. So basically anything except C, which is to say, and you're thinking to yourself, yeah, blame the technology. Yeah. So sorry. Possible answers are everything except 35 versus 50, right? So all of these things. Yes, that's right. Yeah, that's right. Okay, so let's do some math. One of the things that we've talked about a number of times is people taking a data set and writing down a model of the behavior that would have generated the data set, right? Like here's a bunch of data on consumption, savings, and borrowing choices. Now let me write down a beta delta model of people's consumption, savings, and borrowing choices, which is exactly what you have in the problem set. And let me estimate the beta and delta parameters that will do the best job of explaining the observed data. And we've seen this in the food stamps study. We've seen it in the consumption, savings, borrowing study. We've seen it in a number of other places. At one point, we saw that being done in the equity premium puzzle myopic loss aversion paper. This is a thing that people like to do a lot. I have attempted it myself. It's not easy stuff. But here's how we could attempt to do that using these data.